Okay.
So we're gonna use the same webinar for the presentations at the end of the day.
That's right.
We
So
should,
basically, this will just be running all day on my computer, and people just rejoin. Sorry, what were you saying?
and then for the presentations at the end, we can do allow to talk or like.
No, what we're gonna do is people will sign up to be presenters and give me their info, and then I can add them as panelists.
Yeah, gotcha.
And then they can join and they'll be able to talk. They use that link.
Cool. Yeah, I see that promote to panelists thing now, since I'm the host. And then for the YouTube.
Oh, you can just do it on the fly on attendees. Is that what you can do?
Yeah,
You don't even need to send it to them? Okay.
No, you can just go to attendee and then like under more, promote to panelists.
Yeah, I don't have it anymore because I gave it to you. But
yeah, well, here we can both have it. Hold on, I'm gonna. Well, I'll just make you back the host because I have the video going.
yeah, I'll check it out after you're done hosting.
So for YouTube, should we stream the morning stuff and then we'll have a different stream for the.
I think so, unless you want just the slide to be streaming all day.
I don't know. I feel like it's not like hopefully. I mean, obviously nobody's gonna be sitting there watching it, but maybe people will have it up on their computer and then.
It seems like somewhat a waste of energy to have a stream going all day.
Yeah.
With a slide. So I agree. We can just take it down and say,
go back to the website, find the new link. Yeah. All right, we'll do that.
Not that anyone's checking out my expressions, but if I make weird faces, I'm also on another meeting over there. So I'm not rolling my eyes at you. I'm rolling my eyes at something else.
By the way, Karen, still haven't received the email. I think, yeah, there might be some issues.
Seems like Eventbrite's have, I don't know if there's been a lot of DDoS attacks this week. I don't know if that's what the problem is with Eventbrite or not. I could resend it to everyone and just, I mean, I can certainly send it to you. I got it. A few other people said they got it.
Okay, so maybe it's just problems with the...
Well, the problem is that it seems like you can't tell who it didn't go to.
Right.
You know?
Yeah.
So either people have to reach out to me directly or I have to just like blast it to everybody.
Yeah, I got the link from Eventbrite this morning.
Okay.
I'm trying to sort out Powell, by the way. Yay! You made it.
Hello.
You made it.
Yes.
You can't see me.
I, deci-
Sorry about that.
I decided to give up and install the application.
Sorry.
I was successful avoiding Zoom application
For a
up till
while.
now, but
Yeah.
no escape, I guess. Okay, sorry about that. So can you hear me well?
Yeah.
It's more or less okay. Okay. My
We
kids
can see you,
started
although
school,
if
so I hope their Zooms won't interfere, but
we can see you pretty well, but it would be if you had a light source to go on your face, that might be better because you're a little bit in shadow.
yeah, I have a top light. Let me think. Okay, I will try to organize something. Okay, 1 sec.
For the attendees starting to join, we'll start in about 11-ish minutes.
There is shadow. uh, is that any better or not really?
I think it's good. What do you think, Matt?
I can bring another light source because now I have top light and light on my left, but I see there is a shadow now from the side, so not sure. Let me try it. Something else. about now? I'm not sure if it's better.
Couldn't hear you, Matt. Can you, other people hear Matt?
No, I can hear him.
No.
We can't hear you.
How about now?
We can hear you now.
Okay, cool. Stupid hardware muting on my headset. Yeah, I was just saying your video looks pretty good. It's hard to, it takes a lot of work to get it looking decent. My setup from yesterday was like, took a lot of trial and error.
But I'm not sure if it's better. I have now 3 light sources, so I'm not sure if it wasn't better with just one. What do you guys think?
Alan says much better.
Okay.
Alan Jude. So I think you're good.
Yeah, I would say the only weird thing is that it looks like one light source is maybe below you. So you have like the shadow of your glasses is like going up. It's like you have
Yes.
double eyebrows.
I'm not sure if this.
I think that looks good. Even though you're a little darker, I think that looks good.
Yeah, it's less weird, I guess. And
Nice.
okay.
Cool. Yeah, we'll get started in like 5 minutes. I'll just let folks know about what we're going to be doing today, and then introduce you, and then
I'll try to share my screen. So
yeah,
let's see if that works. Should I leave Slack on, or?
Should definitely not have notifications on when you're sharing your screen. But questions will be coming through primarily through Zoom, the Q&A link that's at the bottom.
Okay. I think I disabled notifications in Mac, and this is also not my main screen. So
okay.
I hope that even if something sneaks in, it won't be visible.
Yeah, I just did the disable notifications on the Mac, the like do not disturb mode, and that worked pretty well.
Yeah, that's what I did. Okay, I cannot share my screen because somebody else.
Because I'm doing that. Yeah, I'm sharing mine. Matt's going to go first. I don't know if he's going to have a slide.
I'm going to share the slide that you're currently finishing up.
Okay.
But
if Paolo wants to test it,
yes, definitely. I would like to test it. I would like to see if I can share just one application.
Yeah, and then test like if you when you full screen that, or if you full screen that, test to make sure that works as well.
Okay. Okay, no permission. Let's try again. Okay, looks better now. Okay. Can you see my slides?
Looks great.
Okay. Okay. I guess I'm ready.
Awesome.
So let me disable screen sharing. Okay. So Matt, you start, right? So
Yeah.
Okay.
All right, welcome back to the second day of the OpenZFS Developer Summit. I'm Matt Ahrens, and we're going to be continuing with one talk today. Actually, let me show you the, let me share my screen. You can see what we're doing. All right. So we're going to have one talk this morning by Pavel about block cloning and reference tracking. And then we'll spend most of the day with the hackathon. So the idea of the hackathon is to give folks a chance to work together with people that they might not normally work with. You know, normally this would be all in person and we'd be sitting next to each other. But so online, we're going to need to do a little bit more work to organize. There's a spreadsheet which has some ideas for the hackathon. Let me see if I can show that to you. So I see folks have already been adding ideas there. We'll have an opportunity after Powell's talk. Folks will have an opportunity to share their ideas verbally. So to kind of pitch your idea and see if other folks, see if you can get other folks to join in with you. Because as I said, the idea is to get people working together, hopefully not just by yourself, although that is okay as well. And then at the end of the day, we're going to come together at 4 o'clock Pacific time for presentations. So you can tell us what you worked on today. It could be just like, I had this idea, I vetted the idea, or I did some design work, or I talked with somebody about how we might approach some problem. That's cool too. It doesn't have to have a demo, but demos are certainly welcome. You know, we're all systems programmers here, so we know that the demos are usually like you type ls and then it's like, woo, ls actually give me the list of files, hooray. That's the best kind of systems demo. It did what it was supposed to do. And then we'll have hackathon awards. So there are prizes available. Here you go. So here are the great prizes that you can choose from. We wanted to bring a little bit of San Francisco to you. So we have some coffee that's roasted here in San Francisco. This is what we had at our at the Delphix office in San Francisco, where we've had the hackathon a few times, and some food gift boxes. This one is kind of a coffee-focused one. This one is more of you know, lots of treats. This is from a place up the street from my house that has kind of collects all great locally made foods. Here's some locally made chocolate, which my kids love to go visit the chocolate factory there. And then we have our you know, usual staple of electronics, work from home, things that help you work from home, as well as kind kind of pandemic inspired. I know people are getting into new hobbies and stuff, so we have some things that'll help you with your hobbies, whether those are musical or home repair focused. All right. So logistical, we'll get to the logistical notes for the hackathon after Paolo's presentation, but rest assured, we have we've sorted out how that's going to work. So let's go to Paolo. I'll introduce. Paolo's going to be talking about cool new idea about block reference tracking, and if you like what you hear, then come talk to him at the hackathon too. All right, take it away, Paolo.
Okay. Hello, everyone. Me being the only presentation today that puts some pressure on me, but hopefully I can manage. Okay, let me quickly share my screen. Okay. Okay. So block reference table. So what's the general idea? So general idea behind this feature is ability to reference one data block from two separate files. So a lot of people actually, when they hear that ZFS is copy on write, they wonder why this feature is not already implemented. It must be so easy. You can think of this feature as a let's say file cloning. So you have a file, you want to clone the file, and basically both copies of the file are now have this copy on write property. So if you modify one file, it doesn't modify the other file. So it's not a hard link, right, where you have two separate file names, but this is basically the same file, same data. You modify one file, the other one is also updated because it's actually exactly the same file. It's referenced by two different file names. So this is different. Two separate files, they have their own properties, their own permission, ownership, etc., but can share data blocks. It turns out that Linux already has this feature through with ButterFS. There is a special ioctl, and there is an option for CP called reflink that you can use to clone a file. And there is a dedicated system call on macOS, clone file, which also allows to do exactly the same thing. So what are like general benefits of feature like that? So definitely the main benefit is space savings when cloning files. If you have large files, you just want to modify them slightly, you can just copy the file, and it takes no additional space. Another huge benefit is when you try to recover a file from a snapshot. So you accidentally deleted a file and you want to bring the file back. So now if you just copy the file back, it will consume additional space because the data blocks will be copied. It will allocate additional space for all those data blocks. So some people complain about this. So it would be nice to be able to not to pay the cost to just recover files from a snapshot. Also, such a copy will be super fast. So if you clone a file, we don't read data blocks. We just read the parent blocks. We just need block pointers that will clone. So we read and write only a fraction of of what is read and written when you do regular copy. So it should be extremely fast. And another benefit is that you can move files between data sets. This has some limitations. I will mention about them a bit later. And some may think, why do we need this if we already have the duplication? It serves pretty much the same purpose. And you can think about this block reference table as a manual dedupe, that you decide what you deduplicate. But with block reference table, there is no cost on write. With the duplication, you have to look up, you have to go through dedupe table. So when you write and you have large dedupe table, there's a lot of problems with that. If it doesn't fit in RAM, you have all those performance problems. So it can be quicker, it can be slower. With block reference table, if you do a regular write, we don't touch block reference table. So there is no additional cost at all. If you do, of course, file cloning, there is a cost on write, but it's much smaller. As I mentioned, the copying it will be super fast. And it works with any checksum algorithm. You don't need cryptographically strong checksum in order to be able to use block reference table, because we don't care about the checksum itself. And another benefit is that with dedupe table, and because we use cryptographically strong checksum, the blocks are scattered throughout the entire dedupe table. So if you have one file, few blocks, you may end up reading from totally different places in dedupe table. With block reference table, there is a high chance that all the entries that you need are in very close to each other. So as I mentioned, dedupe tables can grow very big. Dedupe table entry is pretty large. This is in-memory size of dedupe entry. So it's almost 400 bytes. It's 1/5 of this for block reference table, which also means that you can fit much bigger block reference table in RAM. So with dedupe, the big difference is that in dedupe table, you have a lot of entries, most likely, that have only a single reference. This is not possible with block reference table. There are no entries with a single reference. If there are a single reference, we basically just remove the entry from block reference table. So the table only contains the reference that are actually meaningful, that actually reference blocks that are referenced more than once. And as I mentioned already, dedupe table, all the blocks can be scattered throughout the dedupe table. So other costs and no costs. So as I mentioned, there are no penalty for regular writes. There is no penalty also for regular reads, of course. So, but this is similar to dedupe. If you don't use this feature, there is no cost. So simply, if you're afraid that block reference table can also grow big and there can also be performance problem, you just doesn't have to use this file cloning facility, and basically it will just work. There is a cost when you free a block. So on every free, we have to consult block reference table. That's the difference between this feature and dedupe. With dedupe, we have a special flag in block pointer, the D flag, that says that this block is in dedupe table. So if there is no D flag, we simply don't consult the dedupe table. With block reference table, there is no special flag in block pointer. The reason being that we want to clone existing blocks. So when we wrote the block, we simply didn't know if this block is going to be cloned or not. So there is no special flag, and of course we cannot modify block pointer. So simply on every free, we have to go and check if this block is referenced in block reference table, and if it is, we have to decrease the counter. If it's not, then we did some extra work. But as I said before, if you don't use it, there is no cost, because the table will be empty, so you don't have to worry about that. And when you just want to use this feature to move files between data sets, let's say, the table won't grow, because it will grow only for a short while when we put the reference into the table. But when you remove the original copy, we will remove the entries from the table. So the cost is only well, the table will grow only for a very short amount of time. So when it comes to design, as I mentioned, there is no BP rewrite, so we cannot modify BP. So we cannot either put a special flag, or we cannot put a reference counter into block pointer. That would be, of course, like obvious idea to just increase some counter within block pointer, but block pointers cannot be just modified, so we need additional table. When we clone, we don't read data blocks. It must be super fast. Just the parent blocks, just the block pointers. We just add reference to the table. And I hope that this feature can be always on. So I would prefer not to have a special property just for that, because as I mentioned, if you don't use this feature, there is no additional cost. And block reference table entry is extremely simple. It's just we just need to say which VDEF and the offset of the block, and of course reference counter, but the entry itself is extremely small. There are some limitations that it's worth mentioning. Blocks that are cloned, this information cannot be sent over. So we cannot preserve this information when we do ZFS send. This might be a bit, let's say, discouraging, but the same with, there is similar limitation with dedupe, but because of the checksum, dedupe can reconstruct the, basically when we send and receive the block, dedupe can figure out based on the checksum that this block have more entries and simply update dedupe table. Here, we have no idea if the entry is on the target system, and the target system has no idea if the data that is coming have more references. So if you use block reference table a lot, and you will send data set like that over, unfortunately, it will be much bigger than the original data set. So that's a bit disappointing in my opinion. I would like this to work across data sets. I would like to be able to move or clone files between data sets. But of course, I don't want this to work when there are different encryption keys. So this is similar limitation to dedupe. If the encryption key is inherited, like through ZFS clone, then that should be fine. But if it's totally independent encryption key, then we won't be able to clone files between data sets with different keys. And of course, between a data set that it's not encrypted and data set that it's encrypted, and the opposite. I would like this still to work between data sets with different compression algorithms, because you still don't pay the additional price. So even if you clone a file to a data set with compression off, a compressed block to data set with compression off, or the other way, I would like this to simply work, because when you start to override the blocks, we will simply use the algorithm configured on the specific data set. Okay, I was trying to be brief, but it really went quickly. So I guess there will be some more time for questions, but I will just mention status of the project. So I don't want to put your hopes too high. This is just my hobby project, so the progress is very slow. I was able to hack some very early prototype. I'm using additional system call, but I'm not yet sure if this is best idea. On FreeBSD, you can register additional system calls from kernel modules. I'm not sure about Linux, probably too, although ButterFS is using additional ioctl. So maybe this is a better way to go. But for now, I'm just using additional system call. I am able to read block pointers to some extent. I can update the table on write. There is some things that already work, but I'm sure there are a lot of corner cases we have to consider that are not considered at this point at all. So it's a very early prototype. So if there are any questions, I'm happy to answer them.
It looks like there's a few questions. If you click the Q&A, do you want to read them, or do you want me to read them to you?
Okay, sure. 1 sec. So
Yeah,
let
you
me.
can probably stop screen sharing, and then you'll see the in the Zoom. There's a Q&A with there's 4 questions queued there.
So a question from Crest first. Could this be used to implement rebasable thin jails? Okay. Definitely you could, because I think that the story behind that is that if you would like to implement jails on top of ZFS, a common practice is to use ZFS cloning. So with ZFS clone, you have initial free copy of your based system. But when you update the jail, you simply have to overwrite the files, and you start to lose all the savings, because ZFS clone only gives you the initial savings. So I think yes, definitely. If you will just install the updated system files from some template, and you will use file cloning for that, and not just regular copy or install tools, which of course we can extend copy, CP, and install to use file cloning if feasible. So then yes, definitely, and you can keep the savings even after updating your jails. I hope that's answered the question. So Christian is asking, what is the reason why the BRT files not be sendable? So the problem here is that when we send the file, we don't really transfer any information about block pointer. Matt can correct me if I'm wrong here, but at the DMU level, we lose that information. So we simply just send data blocks, but at the destination ZFS, they will have totally different block pointers. So there is different VDEF, different offset, and this is what we use to reference the blocks. So we lose that information when we send. It's totally different on the destination data set. So simply, and especially that I would like this to use across data sets. But even within a single data set, we cannot assume that there is a copy of the block already, because ZFS send and receive is one directional. So we discussed that initially. If anyone has ideas how to address that, I'm happy to discuss that. But at this point, I think that's unfortunately a limitation of this feature.
Just to clarify, there may be some confusion about whether the files, are you allowed to ZFS send something that has BRT stuff in it?
Okay. So yes, definitely, because when you read the file, or when you read, you simply don't touch BRT. So this is just regular files, and so yeah.
Yeah, so you can send it. It's just that the block sharing of BRT doesn't come across with the ZFS send. Is that correct?
Yes, although that's an interesting question. If I clone a block that it's much older, it will be included in a specific snapshot range on the destination data set. So
maybe you could detect that.
Yeah.
But in any case, the discussion is really about could we preserve the block sharing of BRT, not about whether send is going to work at all with this.
Yeah, so preservation, I think it's not possible, but
cool, thanks.
Okay, question from Johnny. Why do we need another table? Can't we simply use dedupe tables? So I was initially I was thinking about that, but I believe that additional table is a better option because it's much lighter. So the entries are much smaller because there is no checksum. It's simply VDEF, offset, and counter. And also dedupe table is a bit different. Like I mentioned, we put every single block into dedupe table, even blocks with a single reference. So with BRT, there are no such block with single reference. So if the block reference count drops to 1, it's removed from the table. So there are different dynamics. It's also different way to clone files, because we have to do special read because we don't want to read the data, and we have to do special write, because with dedupe you actually write the data itself, and then within the ZIO pipeline you decide that after calculating the checksum, you decide if this entry should go to well, you decide earlier because the dedupe property is set on the data set, but basically you have to provide the data that should go through ZIO pipeline, so you can calculate the checksum and either put the block into the dedupe table or just write the block to the disk. With BRT, we don't want this last step. There are no ZIOs with the data itself. We finish at the block pointers, and we have no data.
Yeah, I think a big reason that you wouldn't want to combine it with the dedupe table is in case you're also using dedupe. You don't want to, like when you're doing a free, whenever you're doing a free, you have to look in the block reference table. You don't want that block reference table to be larger than necessary. So you don't want to be, you wouldn't want to have to go look in the dedupe table when you're doing a free that doesn't involve dedupe, but might involve the block reference table.
Yeah. So my hope is that BRT will be much smaller. Of course, you can always go to extremes, but there is you need to make much more work to actually make BRT a performance problem, because as I said, it's much more compact and specialized. Okay, question from Crest. Could this accelerate copy file range for the NFF server? To be honest, I'm not familiar with the system call, so I'm not sure how it works exactly. So maybe somebody else know how it works.
I think that it would be able to take advantage of this. It's basically like copying a range of a file to another file.
So that's interesting, because there are two approaches I'm considering. So one is a clone file system call that basically clones entire file, but this can also be implemented as cloning individual blocks. Then you could punch a block in the middle of a file that is basically a clone block, but of course you have to preserve like alignment. So you cannot punch the block anywhere into the file. It has to be at the block size boundaries. So it's a bit limited. So if a copy file range allows to move the data into any place within a file, then it won't work for general case, but it can work for some specific cases where you preserve the boundaries.
We're running a little bit short on time, so I'm just trying to answer some of the questions in text as you're typing. But we probably have time for like one or two more if you want to answer them live.
So question from Alan. What type of data structure does the BRT use? Is it stored at the top level of the pool? Yes, it's basically, I simply try to reuse as much dedupe code as possible, or at least use it for more like an inspiration, but it's very similar to dedupe in that regard. So it used the same data structure, similar data structures in place in the same exact place in the pool. So there's a lot of code that is reused from dedupe. Okay, and question from Tenzin. If the source snapshot removed, what happens to the copied cloned file? Does the file get copied up to the live system? That's a very good question, and to be honest, I didn't figure out yet the interaction between BRT and snapshots. There are some potential questions how this fits into intuition of the user, how the block is, the life cycle of the block. because as black pointer is not updated. So so this is something I still need to investigate. Okay. So last question from Christian. You could have the Zio hint whether it used the BRT or not. So yes, we do send this information through Zio pipeline that we are using BRT, and there is no data, and it has to be it has to just update BRT table. So yes, it handled in a special way.
Cool. Well, thanks everyone who, thanks Powell for telling us about this. This is a really cool idea. And thanks to everyone who asked all those great questions. Sorry, I had to jump in there, and hopefully I gave the correct answers. If Powell, if you want to, you can look through the answered questions there and type corrections to anything that I said wrong. So we're going to transition a little bit. Oh, so I should mention we had another talk planned for today that unfortunately needed to be canceled for personal reasons. The speaker needed to, couldn't make it. So we'll try to get that organized at a later date. But now we're going to transition to the hackathon planning. So let's see, I'm going to share my screen. There we go. All right. So this is sort of necessarily going to be a little bit more casual. What we're going to have folks do is folks who are interested in leading a hackathon project, we're going to add you so that you can share your audio and video and tell us about your project. So there's a few folks that I've already talked to that I've marked in bold here, but if you are interested in leading a project, you could go ahead and mark yourself bold in here, or I guess do a Q&A to ask a question and let me know, and then we'll add you to the webinar. Where is the right? Oh, I might need to stop sharing in order to control this. But this is a spreadsheet. The spreadsheet's linked in Slack. It's also linked in on the website, and we'll use this to coordinate. We're going to set up Zoom links for each of the projects that's being worked on today. So if you have your own Zoom set up, then you can use that and post the link in here. Or if you would like us to provide them, we have a bunch of Zoom meetings set up so that folks can use those, and we'll put the links in here. Let me see, any questions? How do I go back to, here we go. Any questions about that? Post in Q&A. If not, I'm going to call on I think I have 3 or 4 people that I know want to talk here. So Seraphim, maybe you could go first. I'm going to add you as a panelist. All right, cool. So Seraphim, you should be able to unmute and share your video and tell us about your newcomers session.
All right. Can people hear me well?
We can hear you.
Right.
You look like you're in the witness protection program, but that's okay.
I'm sorry, it's just the lighting on my face. It's so bad. But yeah, if you see on the Hackathon Excel spreadsheet, there is a separate spreadsheet for all the newbies projects. The whole point why I wanted to organize this is for people who, you know, they've been using ZFS and they're kind of interested and they want to like try, you know, take a stab at like developing some code for it, or, you know, just even want to like try to compile it from scratch or something like that. Even if you, you know, don't have all the developer tools and you just have ZFS installed, there are projects there that, you know, are kind of like tangential to ZFS. Like there's some debugging tools, there's some like diagnostic and troubleshooting. So, you know, like you can potentially like pick up a project that, you know, you can try out your own preferred programming language and other things. And I think there are also a couple even more high level, like updating things on the wiki page and stuff. But yeah, if you want to give ZFS development a try, please join us.
Awesome, thanks. So if you're interested in joining Seraphim, you can add your name to the spreadsheet, and we'll be posting the Zoom link for that momentarily. So after, the way this is going to work is after we do all the pitch sessions, I think this webinar will continue to exist throughout the day, and you can come in here and like type questions to us or whatever for the organizers. But for the most part, folks are going to go join these breakout sessions or work on your own. And then we'll come together again at 4 p.m. Pacific time for the presentations on this same webinar. So next, Mohammed, do you want to talk about Minio? I think there you are. Cool.
Yes. Let me just make sure. Okay, great. I don't know why my background is.
Oh, we can't hear you. You changed your background and there we go.
Can you guys hear me okay?
We can hear you. Looks like Mohammed's having some technical difficulties. Why don't we, maybe you want to try again with, oh, I see you're sharing your screen. I can see that. We can't hear you though.
How about now? I see.
There we go.
Okay, great, awesome. Let me know if at any point my audio goes a little shaky. But so just a quick one. This is totally a pet project. I just didn't have time to work on it. So I thought this hackathon would be a good time to kind of work on it with people who actually work on it all the time, like ZFS. So the idea is that using MinIO, which actually just allows a very simplified S3 layer, to use ZFS as the file system underneath it. So if you go to their website, they usually recommend XFS, and I tried that and used with SSDs, with HDDs, and other things, and just wanted to see how ZFS would work, and wanted to get the community's opinion on if this is a good match or what should be kind of studied in this context. So one way to kind of do it is, RAID Z. The other one was just like each individual drive becomes a VDEV and a ZFS data set on its own. And the other one is this. And I tried actually both of them, and I would love to know what people think about how would be a good way to do it. I personally have it currently set up this way, mainly because I think MinIO provides the erasure coding. So I think it's better to just do it at the top rather than at the bottom. Obviously, why would you want to do it? At some point, you can actually then scale it out, because MinIO allows you to kind of scale out across servers. This is a simplified one for people who don't quite understand, but really what's happening in MinIO is that you're running in each MinIO on each of the servers, and then they're talking to each of the devices, and there's a lot of cross-pollination going on. So that's like later on. And as you know, we actually created our own object storage called Cortex, and we open sourced it. It actually wants to consume raw disks, and there are some other object stores which do that too. So my second phase would be to actually kind of figuring out if ZVol would be a good fit to consume within our own object store, which is the Seagate's object store, because it likes to consume raw block devices. And again, would it be better to just do a Z pool and then carve out ZVols, or have individual ZVols on each of the devices? So looking for some feedback from the folks. So what do I have currently for the hackathon is I have a rack with 4 different servers. Actually, it has 7, but 4 of them are are set up. So one of the servers has this ZFS, their individual ZFS data sets on each of the spindle, and with MinIO set up, connected to a 25 gig switch with a load generator on the other end. Then I have one other server in the same rack, exactly the same configuration, even the same drives and everything, but with XFS set up. And then a third one with VDO. So those, I'm pretty sure everybody here is familiar with, but VDO is also one of the layers which allows you to use, to do compression and dedupe. And that's just for comparison reasons. So basically a load generator and 3 servers, one server with ZFS, one with XFS, and one with VDO plus XFS. So just to kind of get people's, interest up, this is what I have currently running, and this is what it's showing. Obviously, my sample size is really small, and one of the reasons why it's probably the ZFS in the async mode is choking or pretty much saturating the 25 gig switch for the reads, because it's coming from the ARC, I suppose. But just to kind of tell you guys how I've been seeing it, and it's totally preliminary, please. I'm pretty sure there's a lot of tuning that can happen, and that's what I'm hoping that maybe we can do during the hackathon. Some of the questions I'm trying to answer, and happy to kind of include more of it. And I'm not hoping to answer them today, but maybe later on. What is the recommended way of consuming ZFS for object storages like this? Is it a recommended way? What am I missing? Because every time I go Google, like, hey, can I create a ZFS on a single disk? Everybody's kind of hissing around like, this is not a good idea. So, but anyway, the other one is like, in particular, I actually did a little while ago, like a sync with MinIO on top. Obviously the performance really drops, but to me, that's not necessary. And I would love to have some feedback, because in my opinion, MinIO is providing the durability part. Also, MinIO provides compression. There's a lot of other object storages that provide the same way. They don't provide dedupe, by the way. So one way to kind of look at it is compression better at the object layer or at the individual sharded, at a disk level, so to speak. So also, I'm using S3 Bench, which the data it produces is not compressible. So how do I, kind of do this type of comparison at the object layer, at the disk layer? How about the solution? Once I have it, I have a 5-server rack. So I was going to install whichever is the optimized way of deploying ZFS plus MinIO is actually going to do it.
So Mohammed, can I just break in here for a sec? It sounds like you've thought this out pretty well. And I think maybe folks have got an idea of like what it is that you'd like to discuss. Did you have any more slides that you wanted to flash up for us?
Thank you.
Okay, cool. So I think this is super great. And there were also some questions I think you may have been recognized from your previous participation at the conference. There were some questions on YouTube about like the work on those dual actuator drives, which are pretty cool. So I'm hoping that that folks could, and there's a question here. Yeah, hopefully those folks can join in your hackathon session and try to sort that out. Do you want us to provide? Do you want us to provide a Zoom meeting for you, or do you...
I don't have a Zoom account.
Okay. Cool. So Karen, you could set that up for Mohammed. Thanks a lot.
Thank you.
And apologies for cutting you off. I just want to make sure that we get, everybody has a chance.
Yep. Sounds good.
Cool. So I think Christian, you're up next. Go ahead and tell us about your idea.
Okay, so I haven't prepared any fancy slides, and it actually
That's fine.
A very short-term idea. So with the ZIL talk yesterday, I thought it might be a good idea to make the ZIL implementation pluggable. It's also related to a project I'll be working on the next 6 months. So yeah, it's basically refactoring work. So not something you can show off easily, and I doubt it will get done within a few hours. But I'd love to see like design ideas or points of contention where it's not as easy to isolate the ZIL functionality just yet. So yeah, I'd also like a Zoom link provided. And if anyone's interested in that, please join. Thanks.
Thanks, Christian. So Karen, you'd set up a Zoom meeting for Christian as well. Mark, maybe you want to go next?
Yeah. So as I mentioned yesterday, what we want to do with D-RAID is sort of leverage the concepts from the RAID-Z expansion work to apply it to D-RAID. The real difference here is that, of course, because we have a more virtualized group layout than we have in a strict RAID-Z layout, we can actually sort of expand the number of groups in D-RAID quite easily, and so we can retain the group size. And I think this is a huge advantage over the RAID-Z expansion work, but it still involves the same job of relaying out the data across a new set of groups, and so you need to have space preserved and redo that work. So it's an interesting and potentially achievable sort of hack, at least sort of as a prototype, this afternoon. So folks interested should definitely join in. And I do also need a Zoom link.
Cool. Thanks, Mark.
Yep.
I will definitely at least stop in with you. Since, obviously, I have some thoughts on how
Yes.
RAID-Z expansion works and how we could apply it to this.
That'd be cool. Yep. Brian promises to join as well.
Awesome. Let's see. I think those were everybody who marked themselves bold. I may start asking other folks. So actually, I should. Howell, do you were you interested in having folks work on the block reference tracking with you today?
Definitely, that would be helpful. Although I do have some obligations today, I have to. But if we can organize some slot, then definitely, probably not like. If there's anyone that would like to answer some questions, some like very deep ZIO pipeline like questions, then I would really appreciate that.
Yeah, I could probably help you with that, and I also might volunteer George Wilson to help you with the ZIO pipeline stuff.
Yeah, George's presentation was very helpful. I saw. We need more like that.
Cool.
Thank you, George.
And should we provide you a Zoom link?
Mm-hmm. Yeah.
For that? Cool. All right. I saw a few other things added. I'm going to maybe pick on some folks. I'm going to pick on, I'm going to see if Jorgen and Alec are here and see if they will. Oh, great. Alec, you're easy to find because it's in alphabetical order. So I'm adding you as a panelist. Would you like to talk about updating the website and documentation? I think this is something that probably a lot of people could help work together on, since it's so accessible. You don't need to like be a developer at all. There's a lot of stuff there that could be done to improve that.
Right. Yeah, I mean, I just looking at the website mainly, you can see there's like the features and some of the benefits and the easily digestible information that we have out, like introductory videos and stuff like that. Something that people would expect to see coming to that website could be added. And then I know there's the github.io page that's also got a lot of really good stuff that's not really linked together in like a comprehensive way. So I was just thought about working on that and making it better. And yeah, if anybody wants to help, I think I have access to at least the wiki. I'm not sure how the site works, the github.io site works, but I'll figure it out. And I sent the Zoom link.
I think that the GitHub.io one, you can just open pull requests against, right, if you find the right repo there.
Mm-hmm. Right. So I have a Zoom link, but it's a personal one, so it's a 3-person limit. So I'm
Okay.
depending on the attendance.
Yeah, I think that I hope that that session will be well attended. So I'm assuming that we have enough. Looks like okay. You provided the personal link there. Do you want us to replace it with one that can accommodate more people?
Sure.
Cool. Thanks. Looks like Karen just did that. Right. So Eric, I saw asked a question about the pool compatible features, which Josh had planned to talk about and lead a session on today, but wasn't able to make it. Yeah, I think that would be great if folks want to work on that. There was actually a pull request opened just recently by someone who had started implementing that and got pretty far, I think. I want to find their name and see if they're here. I'm looking in the I'm looking in the pull requests. Let's see if I can see it. I'm not reading quickly enough. Oh, somebody posted it for me. Okay, Colm. I'm gonna see if Colm is here. I don't see him. I don't see him. So yeah, if folks are interested, so Eric suggested gathering in the newcomers room. I think that that's a great default place to organize for projects that don't have their own rooms, and then we can create more if we need to. For folks that want to work on that on the compatible features flags, I would suggest taking a look at that pull request and code reviewing it or see what is left to do. I know one thing that was left to do on that was adding the actual list of like what features equals 2019 is this set of features. Features equals like current or compatible or whatever is this set of features. So adding, I think that those were managed through just like a set of files. So adding those files and you know adding them to the packaging and ZFS make and all that stuff. Cool. Anyone else? Anyone else who would like to pitch their session? Ask a question on the Q&A, and then I'll promote you as a panelist. For the rest of the day, we'll mainly be coordinating on Slack. So if you should have received a Slack invite if you are here in the webinar on Zoom. For folks on YouTube, if you would like to participate, you can send me an email and I'll add you on Slack. Also, the Zoom links are in the spreadsheet. And then for folks on YouTube, we're going to end this live stream shortly, and then we'll start a different YouTube live stream at 4 o'clock Pacific time with the presentations. Oh, thank you. Eric was able to actually read the pull requests and find it. So it's let's see. I don't know if folks can see this, but I'll type this. So Eric posted the link there in the Q&A. Thomas, I'll promote you. You can talk about distributed ZFS. All right. I've promoted Thomas. If you'd like to, you can unmute yourself and share your video if you'd like to talk about distributed ZFS.
Yeah. Never had this. That's Zoom. That's a reconnect. The unthinkable idea, would it be possible to have a distributed ZFS? I'm at the moment interested in what would be the use cases, because I think this could be a path to see if the effort is worth doing such things. So collecting use cases would be my thing. if someone is interested. On Slack, I already got a note of an interested thing. I think it was from Russia. Just looking for the name. It was Fedor Oprov, maybe someone else. It could be a two-headed storage appliance, or you have normal machines in a line and they all share a pool, maybe with read only or read write. It's a lot of work, I know, but not thinking on it, I think would be wrong. If there are Zoom links left, I would take one from you, but I have an own one.
Okay, cool. I'll leave
sorry,
it to Karen to organize that.
Audio from your side. 1 second.
All right. I think that we've reached the end of what we have for presentations for this morning, or all group discussions. So I'm going to turn off your video, Thomas.
Right now,
Karen,
my microphone?
oh, did you have more to add there?
Does my microphone work now?
Yes, it does. Oh, sorry. Were you?
Did you hear what I said a little bit before?
Yeah, yeah.
Thank you.
I think so. So, yeah, we'll add a Zoom link for you.
Thank you.
Yeah. Oh, there, I see it's in there. Cool. So I think that was all of the sessions that people wanted to talk about. If you, so check out that spreadsheet, you can click over there. Karen, are there any more logistic announcements that we should make before we send folks off?
I think you probably already mentioned that folks should just rejoin this link that they use to join this. It'll be running all day with just a slide reminding everybody of the timing. So see you all back here at 4.
Awesome. And we'll see you on Slack to coordinate if you need to do stuff between now and then. And feel free to create Slack rooms for each of the projects or whatever, Slack channels, I guess they call them.
If you need another, if somebody needs a Zoom link, let me know. I don't have any that I've already established, but I can beg, borrow, and steal them from some other folks whose names I recognize on this attendee list.
All right. Thank you all.